In this topic, I'd like to introduce some of the basic ideas involving energy in physics. And it turns out energy is very useful also beyond just physics. I mean, physics kind of forms a foundation for energy, but energy as a word is used in all kinds of different places. I mean, if you put gas in a car, you're actually doing something involving energy there, you could say. Um, so energy is kind of everywhere. Life uses energy in that sense. But really, what is energy? Is there like such a thing as pure energy? Is maybe an interesting question. And my answer to that is no, because looking at our key concepts page here, the first thing it says is energy is a way of keeping score of natural processes. So in that sense, if I say, hey, you threw a basketball into the basket, your team gets 2 points. And if somebody said, well, where are the 2 points? Give me the 2 points. I want to hold the 2 points in my hand. It doesn't work that way, right? It's an abstract concept. Energy in a similar way is an abstract concept, though it's maybe a little bit different than like a sports game where the point is to kind of like be able to keep score and figure out who wins. Energy becomes more of a score keeping kind of analysis system that lets you track how the energy kind of goes from one form into another form in natural processes. And as we go through this chapter, we're going to see a lot of different examples of how you can think about that, because it's a pretty big story, it turns out. But right at the beginning here, I'd like to take care of the fact that energy is measured in joules. The joule is a unit named after James Prescott Joule. So in that sense, like, if I said, hey, a system has an energy of 15 joules, I could write something like this. Here it is, 15. It turns out as an abbreviated unit is capital J. The general convention in physics is if it's named after someone, the abbreviation will be a capital letter, even though it is correct to actually have it lowercase as a word when it's referring to a unit. It's not a proper noun, actually. Energy can be associated with many different things. I just said different things here, but many different things. So many different things that's partly what makes it confusing. In this course, though, we're going to focus on a few of those different types, but I will be talking about in an example in this topic about all the different types that are really out there, many of which go beyond what we're doing in physics 2A. And at the end of the day, we're going to have a system with a collection of some simple formulas and a whole lot of ideas. And we're going to be able to combine those things to analyze systems and be able to predict what happens. And that's really the goal of any system in physics. That was the goal with forces when we wanted to use them to understand acceleration, to be able to compute results about motion. And energy in a similar way, it works different than forces, but it's going to let us compute things about motions and also other stuff. So energy is really quite useful, it turns out.